I'm just going to start recording on this one. So it's a side congruence, triangles, theorem. Okay. So what do you need to prove if both triangles are congruent? What you need is you need how many sides to be congruent? You need about a total of 3, right? 3 sides that are congruent. So if there are 3 sides corresponding and congruence on both triangles, then the conclusion we can make is that both triangles are congruent. Congruent means they have the same measurement and same value. Okay, so that's what side means. All 3 sides. Here, the other vocabulary we're going to be covering is the side angle side. Okay. Here, I'll just make it the side angle side congruence triangles 0. So here you need one congruent side. You need two congruent sides. You may see here you have side 1 and side number 2, right? And the most important part is you have to have a congruent angle between them. Congruent angle in between those 2 sides. Okay, in between the 2 sides. Okay, so that's the theorem. If you have an angle, if you have 2 corresponding angles and corresponding angle as in between the 2 corresponding congruent sides, then you can say that the triangles are congruent. Okay, you have congruent sides and you have another congruent side, right? Let's put that into practice, right? So here, we're going to go to the first example here. I know it's a lot of, I know you see a lot of white markings, white out, but you can just ignore that. So here, you have, to do your assignment, you need to show that how many sides are congruent. How do you know they are congruent, right? We can state that the corresponding sides here that are congruent are segment AC is congruent to segments ED. How do you know? Because they both have how many tick marks? 1 tick mark. And you know that they are also corresponding. Corresponding means that they're the same location on both triangle 1 and triangle number 2. You have another congruent side, which is AB. AB is congruent to segments EF, which is the hypotenuse, or the longer side, which is segments EF. And you have also segments. This is the shortest leg here, which is segment BC. It's going to be congruent to segments DF, which is, once again, they look like they're corresponding. They look like they're both on the same location on both triangle 1 and triangle number 2. Even though it's rotated, you can assume that you can conclude that they are in the same location. Okay. So you have how many sides are congruent? You have side 1 corresponding side, we have another corresponding sides, and we have 3 corresponding sides, right? We have side 1 here, or say side 1 here, and this side 1 is corresponding to this side here. You have side number 2 here, that's corresponding to this side here, and you have side number 3 on the shortest side of both triangles. And you have 3 sides that are congruent, right? Side, you have side, side, side. So using that, if you have 3 corresponding congruent sides, then what can we tell that triangle? Can we prove that? We need to prove that this triangle ABC congruent to triangle EDF. Hold on, let me read your comment. If there are less than 3 tick marks on the triangle. Yes, although we'll cover that more, okay? If there are 3 less tick marks on, so if there's 3, if the third side does not have any tick marks, then you cannot conclude that it is side, side, side. Let me answer that question in the following question, but let me just focus on this one. So you have 3 sides that are congruent. Sorry, another student was asking a question. But I'll clarify that in the next question. So you have 3 sides that are congruent, and if triangle ABC and triangle EDF are both, how can we tell they're congruent or are they not congruent? Here we've proven that 3 sides are congruent, right, on a triangle. So let's try to do a poll. So the answer was side, 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 but let's explain. Here, the answer is side, side, side. Why? It's because how many sides are congruent? All 3 sides are corresponding in both triangles 1 and triangle number 2, right? If all 3 sides are congruent on both triangles, then you can state that the triangles are congruent based on this theorem. If there are 3 sides that are corresponding and congruent on both triangles, then both triangles are congruent. So this answer is number 1, side, 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 triangle, congruent, triangle theorem. It cannot be angle because there's no angle in this. We never found any congruent angles here, right? How do we know they're congruent angles? There's going to be an arc mark, right? What does an arc mark look like? Arc mark would look like this here, right? Did we see any of this in this question? No. So we cannot. We can reject that the side angle side is even a possibility, right? Using deductive reasoning, is all we see is congruent sides. So we just make a conclusion that since I have 3 congruent sides, then I know that 2 triangles are congruent because of the side, side, side congruent triangle theorem. Okay. On to the next one. Okay. Here we're trying to prove that. Oops, sorry. They are congruent. Why? Because of the side, side, side congruent triangle theorem. Never put S as S because I use putting S as because of marginal space. Okay, the next question we're going to be doing is triangle NTP congruent to TPM? Okay, TPM. It is hard to see because you're looking at 2 different triangles. What you can do is you can separate the 2 triangles, right? When you see the 2 different triangles, then you have the 2 congruent sides, which is NP, segment NP, right? Segment NP and segment PM. Okay. Sorry, let me erase this one here. We have to still prove that Y is triangle NPT and group is congruent to the triangles PTM. So here, the next one is triangle angle P and angle P is congruent to itself. So we're looking at angle P on the first triangle on the left, and we're looking at angle P on the right triangle on the right. Here, angle P and angle P are congruent because why? They're both right angles. But here you cannot say angle P and angle P. You have to specify what angle are they. So you need to name this angle P and the first triangle has an N on the left side and has an angle on the right, NPT, angle NPT. We're still emphasizing angle P though, right? Here angle P is on the right with the ray of PT, which goes to the left, and the ray of PM, which goes to the right. So angle TPM are both congruent to each other. Okay. So the last one we're going to keep something congruent is, if you watch the video, you can say that these 2 sides, this side is congruent to each other. Why? Because these 2 triangles share the same side of TP. So here you can say that this side of TP is congruent to this side of TP using the reflexive property of congruency. Okay. So now here, our last thing is TP is congruent to TP. So we have three congruency, right? We have a congruency with side 1. We have a congruency in side number 2. We also have an angle that is congruent, right? So here, this is a question a student had was, if this doesn't have a tick mark, can we say that NT and TM are congruent? The answer is no, you cannot say NT and TM are congruent. Why? Because they do not have any tick marks to indicate that they are congruent. So we only have to deal with the information we have this side number 1 that is congruent, side number 2 here that is also congruent, and also the angles that are also congruent. Okay. So here, using that information alone, can we state that triangles NPT and triangles PTM, are they both congruent? Right? Let me put a line here so you don't get confused. And let's just clear it up and see what would your answer be, right? Multiple choice again. Once again, we're trying to prove why is triangles NPT and triangle PTM congruent, or are they not, right? Through the, we're just going to show the answer. So, okay, I think this is a really good number. A lot of you already are getting it. You're understanding it. The answer is side angle side. Okay, good job. So once again, always analyze, right? What did we analyze in the first place, right? We analyze that there's two congruent sides, and you have to analyze also if you have a congruent angle in between those two congruent sides. Here we can analyze that we have side 1 and side 2, and in between them there's a congruent side, angle. Side 1 and the second side that are congruent have a congruent angle, corresponding angle in between them, right? So you can automatically say that they're congruent because of they are congruent due to the side angle, side congruent triangle, triangles, 0. Okay, so that's the answer for that one. Now let's go do our last one, and then we'll conclude today's session. I'm just gonna kind of rush through this, just because we're running out of time, and I don't want to keep you up, and I want you to enjoy your weekend. Okay. There are 2 we'll go over that here, actually. Your question, we're going to actually answer right now. So here we have 2 sides here, and we have here we're going to have a congruent angle. Here I'm going to explain why we're going to have a congruent angle. Normally it's not shown that they're congruent, but I'll explain why after. If you can think about it, then if you watch the video, you can tell why. But here we just explain that the first side that is congruent is BW and TZ, right? That's the first side that is congruent. The second side that is congruent is WR on the first triangle on the left and RT on the triangle on the right. How do we know we're congruent again? Always look at the tick marks to indicate that they are congruent to each other on both triangles. Here, I kind of made this information, or I made a conclusion on this information, and I can prove it. Why? Because these are vertical angles. What does vertical angles mean again? So here you see 2 triangles, but if you take out this part of the triangle, what do you see? You see 2 lines intersecting to each other, right? Whenever you see 2 lines intersecting to each other, then you can state that the opposite angles are congruent. Yeah. And you're gonna ask, Mr. Why can I make the bottom and top part also congruent? You can, but will it help you solve the problem? Here we're just focusing on the angle within the triangles, right? So let's focus on that only. So we're going to say that these 2 angles are congruent, which is angle R on the left, but has the rate of RB and the rate of RW, and angle R on the right triangle, on the right side of the triangle, which is angle R with the rate of RT and rate RZ. Yeah. So talking about the angle R though. Yeah. They are congruent once again because of vertical angles. So using this information alone, right? How could we tell? Can we make a conclusion that they are they congruent or are they not congruent? So let's show the responses here. Students answered, but a lot of students are still confused. Okay, so here, let's reflect on this one, right? This is not the side angle side congruent theorem. This is actually the answer for example number 3 is they are not congruent. Why are they not congruent? Because once again, let's read the theorem of the side angle side, right? The side angle side theorem is stating that you need two congruent sides. Okay, you need two congruent sides, which we have. That's not false, right? But what has to be here is the congruent angle has to be in between those two sides, right? For this to be valid, you need to have a congruent side from angle W and angle T. Why? Because angle W and angle T will be in between those two sides. So this is a question I want to give because some of you might get confused in this one. Yeah. So since angle W and angle T are not congruent, then you cannot state that these two triangles are congruent because it won't follow the side angle side congruent triangle theorem. It has to be the angle has to be in between those two sides. Does that make sense? Hope that makes sense. The last one, it's another example. Okay, let's do example number 4. Example 4 is kind of like this. It's very similar. Here you have two congruent sides and you have a congruent angle, right? But here it's an error that the book made, or they purposely place an error just in case students are just answering as soon as they see two congruent sides and a congruent angle, that they just right away and say, oh, Mr. it's congruent, because they just say automatically triangle 1 is congruent to triangle number 2 and just say side angle side, right? That's false, right? Why? Because if you look at this here, this angle and this angle are not even corresponding. Corresponding means that they're not in the same location, right? They just put an arc mark for no reason. They're trying to confuse you. So this is a question that I want to give as well during our discussion. That actually, if we look at this, it's like number 4, this angle and this angle has to be the closest one that will be congruent to each other. But they chose this. And if you look at it, this looks a lot more larger, has a larger angle than this angle here. This has a thinner angle. Yeah. So that's one of the example that I want to give, and that's the last example. I'll post this up for you to review. So here they are not congruent because the angles are not corresponding. Okay. And also here, if you see here, it does not follow the side angle side. The angle has to be here in between the two sides. This is not, right? Here, this is following the pattern, but you need to have it with the same as both triangles. Both triangles have to have a side angle side to make it make sense. Okay. So this question is just an error and the test of your observance to see if you're actually marking the correct congruent angles and congruent sides. Okay. Other than that, I hope this discussion was helpful. I do hope that it helped you. If you're still confused,